Guys, the winner for the previous video's contest was Shri Parmeshwari Harvester Supramani, and he asked me if we modify the winding of a mini DC motor and increase the torque and speed. So that is exactly what I'm going to do in this project, or to be specific, I'm going to try to do in this project. So you can see this power supply, 15 volts, 3 amperes. It's only 15 volts, 3 amperes supply, so you don't feel a thing. Okay, so guys, the question for today is what will happen if the number of turns per pole on the armature of the motor are not identical? So anyways guys, I searched it a lot on YouTube to see if anyone had conducted a similar experiment, that is converting a 220 volts permanent magnet DC motor to 12 volts DC motor. But since I couldn't find it, so I thought about experimenting it myself to see if it works or not. So let's try it. Note that the experiment is really dangerous, so don't conduct it at home. And guys, I got this permanent magnet motor from a mini blender. Okay, so guys, the motor is completely ready now. Let's see if it can survive the high current that is going to flow through these springs that are going to feed the brushes. So guys, to power it up, I'm going to use this 12 volts, somewhere around 20 amperes DC supply to run this motor, and there is a great chance that the motor is going to burn out. It is working, but like it is heating up a lot. Super hot. Yeah, actually the current needed is too high, and of course the brushes are not able to feed it to the armature. You see, it is working. All in fumes. The full motor is in fumes. Whoa, the brush is boiling. It's too hot. I think it is going to catch fire. Speed is increasing. I don't know why the speed is increasing. Why is the speed increasing? I don't get it, seriously. Seriously, why the speed is increasing? You can see the speed has gained a lot of speed here. Whoa. Whoa, 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 whoa. Yeah, something bad is going to happen, I'm sure of it. Yeah, the motor is running really fast. The brush is going to... It has come to a stop finally. And that brush part has completely melted, guys. You see, it's completely melted. And on this side, motor is like super hot right now. So yeah guys, there is like a few things that we learned from this experiment is that this motor that I used is a 220 volts DC motor, okay, and I converted into a high current DC motor. So like I came from 220 volts to as low as 12 volts, and I gave like a less number of turns, because of which the resistance reduced and the current automatically increased. And then again I also used 3 times thicker wire, so again the resistance reduced, so it needed more and more high current, and obviously the brushes were not designed to handle that high current. So the result of it was that the motor burned out.
Here you can see that the maximum current discharge of a 12 volts 7Ah UPS battery can be as high as 350 amperes. The number of turns per pole for the armature winding of a starter motor are very less, because of which it requires around 14,400 rpm to produce just 12 volts DC. The second drawback is that at such a high RPM, the brushes will wear out very fast, thus making it impractical to be used as a generator. Hi guys, you're watching channel Mr. Electron, and these four what you see are high current DC motors. All of them are rated at 12 volts, but we have to find out the maximum current rating. This one you can see the coil inside, how thick the copper wire is, and the commutators. So here I'm going to use this 12 volts 7Ah UPS battery to find out the maximum starting and running current. Running current, as you can see, is around 2 amperes, while the starting current peak is up to 5 amperes. So that's the high current. Now let's open it all up and see how the armature and the magnets look from inside, and if it contains ball bearings or bushes. Now guys, we also have to make a permanent mark, because it is going to be difficult otherwise when we close it after viewing the inside parts. So it is open now, and that's the armature. Let's close it up. So guys, as you can see that the copper wires are really thick, and yeah, it's like new from inside, although it looked not so much new from outside. The magnets are also in good condition, no problem with that, and the brushes are also very healthy, okay, and pretty big brushes have been used to carry that huge current. So let's measure the wire thickness. You can see it's almost 1 mm. Now let's place it all back. The wire thickness is 1 mm, no wonder it can carry huge current. So guys, in this video I'm not going to do the motoring mode tests, but the generator mode testing, okay. Let's place the screws and keep them held tightly, and also place some WD-40 because it has bushes and not bearings, okay. And this motor that I am placing WD-40 on, this is the piece I'm going to use for testing. This is a large 1 kilowatt DC motor, and this is a small motor, and this is a double groove pulley which I got from Banggood's. Link will be in the description if you want to buy it. And it has like the bolt to tighten up, and it is 8 mm and fits perfectly to the shaft size of the motor. So let's place the rubber belts, and I'm going to use 2 of them because this small motor and the big motor both are going to be under huge load, because I'm going to do the maximum power testing here. So those 2 terminals, brass terminals that you see, to those I have connected 2 wires, and to the wire output I'm going to connect the multimeter pins to measure the voltage it is generating when I run it at high RPM with the help of the large DC motor. This is the DC motor speed controller that I made, and a low high speed and DC socket. So let's do it with one belt at the start. As you can see, it is producing around 5.2 volts. Let's increase the voltage. Yeah, its performance voltage has increased to around 9 volts, even 10, close to 12, and we have crossed 12 volts. 13.24 volts was the max we got. Okay, so the output voltage, generated voltage, was pretty good. So here, as you can see, that I've given 2 more wire connections to connect few bulbs and other loads to it. So first I'm going to start with a 6 volts bulb. You see, 30 watts 6 volts bulb with 2 filaments. It's from a Royal Enfield. Okay, wait a second, it's moving, and you can see that it is glowing brightly, really bright. And obviously it is really easy for the small generator to light it up, and the voltage is around 7 volts, so the bulb is glowing at its full potential. Now this you are familiar with is 12 volts 35 watts bike headlamp bulb. Okay, so let's connect this one, and this one is also lighting up brightly with a little more drop, as can be seen on the multimeter display. The voltage is dropping. Let's increase it to 12 volts by increasing the driving motor RPM. We have reached around 9.5, 10.5, and we are doing around 12 volts. Yeah, around 13 volts was the max we did. And you can see that I've removed the input supply socket, and it is still running because of the flywheel. Okay, now let's move on to even higher power bulb, 90 watts, 100 to 90 watts, 12 volts. Okay, so that has also been connected. This is going to draw even more current, but first we are doing the voltage test right now. Let's see if it can produce that much voltage at such a high load. The load is really big right now for the small generator, and we have reached around 12.5 volts. Yes, the small generator is performing really good. And again, we have disconnected the supply, and still it is running because of the inertia disc on the driving motor. You see how long it takes to stop because of the large inertia disc. It is really helpful in that. Now enough with the voltage test. Let's move on to the current testing. You can see that I've pointed the meter towards 600 ampere current mode, pointing 0, flashing 0 at the moment. Let's place the multimeter at a point that it is visible pretty good, and the current drawn is around 4 amperes. It is the bulb is drawing. Let's increase it further. We have reached around 5 amperes, 5.5, and 6 amps. The bulb is glowing really bright, and we are peaking at around 6.06 amperes with the maximum voltage of around 12 volts. Here, the Starlight 250 watts bulb. This is a really big, it looks small, but it is really big. The filaments are really thick. Now I'm going to power up this 250 watts bulb. This is the biggest DC bulb I've got here. You can see that at the lowest input, it is producing, consuming around 3.5 amps. Let's increase it further. Yeah, we have reached around 4.5 amperes. So somewhat equivalent to the previous bulb, which was 90 watts, and we have reached around 6 amperes. We have crossed the amp rating of the previous bulb. Yeah, 6.27 amps for this one. The amperes were less because that was a 24 volts bulb. Now guys, comes the final shunt resistance short circuit testing. So I'm going to short circuit the wires with the help of an external shunt resistance. Okay, I've given really small loops, and at present at the minimum RPM it is drawing around 5.5 amperes and glowing hot. Okay, it's almost red. 5.5 amperes, increasing the RPM, and we have easily reached around 8.5 amperes, and it is smoking red hot. Let's go further and see what happens. Okay, it has caught fire now. That is amazing. Oops, the filament burned out and it broke. The shunt resistance burned out. Now guys, comes the final test for which you all have been waiting, that I said that I'm going to do the maximum power testing. So we have done the maximum voltage testing, that was around 13.24 at the beginning. So now I'm going to go for the short circuit current testing. Now I'm not going to connect any shunt resistance, but I'm going to connect the two wires coming out from the DC generator so that it creates a shortest path short circuit. That is what it means. And at the lowest RPM it is producing around 11 amperes. It's the negative sign. Let's reverse the wire. Yeah, and now it is positive and 11 point, yeah, almost 12 amperes. That is pretty good at such a low RPM. Increasing the knob and RPM will easily reach around 20 amps, 22, 23. I don't think the belts can survive more. Okay, so I will have to turn it off. And the peak was around 25 amperes. Well, this DC motor is rated at a max of around 32 amperes. So yeah, the performance was really good.